This is a very hard question. My initial instinct here is to arithmetize. I see that there's just like a lot of variables. You got x's, you got a and b and c. There's a lot going on here. And so I would say, okay, if I'm confused by the algebra, then let me arithmetize and pick a number for at least the x and see what happens. Make some of the letters disappear and become numbers. I'm going to save you time though. If you do that, it's not going to work. And I'll explain why kind of at the end. But I really just want to make a point that unfortunately, there are going to be cases where you try the SAT strategies and they don't work. But that doesn't mean that the strategies themselves don't work, right? There's always going to be an error built in. There's always the curveball question that's just weird. And so you're more likely in your practice to remember the times when the strategies failed and then to use that and be like, the strategies don't work. I'm not going to use them. That's bad. That's bad thinking, bad logic. They work 80, 90% of the time. And so you want to make them your default. And it's okay to try them sometimes and then have them fail, because if we use simple numbers like zeros and ones, then they at least fail quickly. And then we still maybe learn something about the question that lets us solve it. I don't like staring at a question for a long period of time and hoping that something comes to me. The strategies get me moving and get me doing stuff and working with it so that maybe I can learn something, and even if I can't solve it. In this case, what we need to do is kind of more of a get back to basics strategy. We need to just sort through all this confusing stuff and say, what do I know? Well, I know that if I have these kind of parentheses things next to each other, my most common move is to FOIL, right? Is to distribute and multiply them out. And so I would say, well, let's do that. I don't know why it's going to help me, but it seems like a thing I can do, so it's probably a thing I should do. That happens a lot on the SAT. So let's just do it. All right, so ax times bx is abx squared. That's then ax times 7 is 7ax. Then 2 times bx is plus 2bx. And 2 times 7 is 14. And I'm not going to write this other equation next to this one. I'm going to write it below. 15x squared plus cx plus 14. We can see where things line up, right? The two 14s obviously match. But this is why we couldn't arithmetize, is we need to see the other stuff that matches. And in this case, we need to recognize that the x squared term has to be this 15. And so if we had plugged a number in for x, we wouldn't be able to tell the x squared term from the x term, the c of x there. And that's because the x's all would have just kind of jumbled up together and smushed. And so we wouldn't recognize those differences. So that is why arithmetize in this particular case doesn't help us. Normally, arithmetize lets us get rid of variables so that we can work just with numbers. In this case, the variables show us the structure of the equation and the relationship between these pieces. And so if we lose the x, we lose the structure. Because now what I want to do is basically turn this into an equation and say, oh, okay, well, a times b has to be 15. And I also knew from the question that a plus b has to equal 8. And so, okay, I can now reason pretty confidently that a has to be 3 and b has to be 5, right? Because 3 times 5 is 15 and 3 plus 5 is 8. Well, now that I've got those numbers, the rest kind of becomes pretty simple here, because I see that even though this is two terms, they both have an x, just a single x, so they must match with this one term. And once I plug in for a and b, those are going to be combinable. So let's do that. That means that 7 times a, which is 3x, plus 2 times b, which is 5 times x, is going to equal c of x. So 21x plus 10x is c of x, so c has to be 31. And only one choice includes that, so it must be D. Now, where did the 41 come from? People always ask, and that's fine, you can. You don't need to know because we still got only one answer here. But I said something before that was wrong. I said that A has to be 3 and B has to be 5. That's not true, because it could also be the case that A is 5 and B is 3. Right? I have no way of knowing, because of the properties of addition and multiplication, which one is which, right? So it's reversible. And if we reverse them, let's see what happens, right? So that would be 7 times 5x plus 2 times 3x is equal to c of x, or cx, and that's 35x plus 6x, and 35 and 6 is 41. So there's the other value. And to be clear, you don't need to do that, right? So once we have one of them, we know it can only be one answer, so that's just done. You should just move on. But you could have made a different choice than I would, and you would have gotten the 41 and had to pick it for that reason. But either way, this is a weird exception to the normal rules of how the SAT operates. I've noticed, however, that they do this more often than they used to, these kinds of questions where the structure of the equation is really important. And so arithmetize won't always work on those kinds of things. That's okay, but if you sense that that's what they're testing, then maybe you don't waste any time with the arithmetize. You go right into this kind of just like manipulating the equations. And so in this case, you should at least recognize that you could FOIL and you should FOIL. In most cases on the SAT, if there's something you can do, it's probably something you should do, and don't worry about the next step. Just do that step and see what happens, and most of the time you'll be pleasantly surprised.